All right, I want to talk about extreme values of functions. Now, by extreme, I mean highest values or lowest. Um, Highest or lowest values. Um, Now, these come in a couple of varieties. Let me say that we have a couple of words we use. We use extreme values. We use the word extrema. We're looking for extrema, that is plural of extreme values. Extrema might be highest, might be lowest. This is just a way with one word to say either, right? Finding highs and lows. We're finding extrema. Now, when I look at a function, okay, how do I want to draw this function? There are different places where there are high points and low points. Um, now, we distinguish them by a couple of different words. There's a difference, for instance, between the highest point that's right here, let's say, and the highest point that's right. Let me continue drawing this function a little bit more. All right, the highest point that's right here, right? That somehow, well, this one certainly is higher than that one. But yet, if it were a foggy day and you were standing on this point and you couldn't see the fact that there was another big mountain over here, you'd think you're at the highest point around. So there's something about this which is kind of locally a high point, where this is more globally a high point. And that's exactly some of the words that we'll use. Our textbook uses the words absolute. So you can have an absolute max or an absolute min, and you'd have what's called a local max or a local min. Right? So this maximum here would be a local max. It's the highest point in the neighborhood, but if you expand your view a little bit, it's not the highest point. So there's a local max there, there's a local max here, there's a local max here, there's a local max here. In fact, there's a local max even there. It's just that this local max is a special local max. This is also the global max. I suppose I should probably give some definitions by what I mean here. Likewise, there's local mins and absolute mins. Uh-oh, see, already I'm using different words. I used global. I should have used absolute. Right? When I learned this, we used global and local, and then some textbooks used, so absolute is sometimes called global, and local is also sometimes called relative, to have a relative max or a relative min. Right? This is not the highest, but relative to the points around it, it's the highest point. Personally, I link global and local together. Those are the words I learned, and then absolute and relative are kind of together, but our textbook uses absolute and local. So anyway, let's give a definition here of what these are. So f of x has a, let's go with local first, a local max at x equals c if f of c is greater than f of x for all x in some interval open interval a to b containing c. Right. So in the picture up here, this point right there, there's a little interval down here on the x-axis around this point c, so that all the function values up here are smaller than f of c. Right? So the maximum happens at x equals c. And so that function value is greater than, I guess I should say, or equal to any of the other points. To be a local min, just turn that inequality around. Right? To be an absolute max or an absolute min, then this is, well, let's write it down. F of x has an absolute max at x equals c if f of c is greater than or equal to f of x for all x. For every possible x that you can plug into this function, if the f of c is greater than or equal to all those other ones, then you have the absolute max at c. Let me distinguish between two things here. Let me give you an actual example here. How about a function like f of x equals minus x squared plus 6x plus 7. Okay. Now this is a parabola that opens downward. Something like this. Okay. And it's got a maximum up at the top here. Now, one of the things we'll learn as we go, and maybe you can see it right now, is that that point at the top is the only place on the parabola where the derivative is equal to 0. So I'm going to just quickly take the derivative here, negative 2x plus 6, and say, well, the only place that it ever equals 0, that's what I want for that high point. So x has to equal 3. Okay. So this is what I want to distinguish. At x equals 3, f of x has an absolute max. However, I want to say, plug the 3 in, f of 3 equals, what's this, negative 9 plus 18 plus 7, so this is 16, right? So the maximum happens at x equals 3, but the maximum value is 16. So I might better word this and say f of x has an absolute max of 16 at x equals 3. Right? Distinguish between what the absolute max is and where it happens. Right? There's times when I'll ask a question like this on a quiz or a test and say, find the absolute max of this function, and people will tell me x equals 3. It's like, no, that's not the maximum function value. That's where the maximum function value exists, but this is the maximum function value. Okay, so let's just distinguish that. Okay, now there are different places here to keep in mind. In subsequent video, we're going to look at how do you find all these places. But one of the things I want to point out is that endpoints are interesting to us because, like for instance, at this endpoint, it's the lowest thing around, right? There isn't anything nearby that has a lower function value. So this is kind of like a local min. Pretty much every math textbook, calculus textbook you'll ever read will not call this a local min. Let's just at least call it an endpoint min. I mean, when we're looking for highest points and lowest points, sometimes the endpoints are going to be very important. Right? If you've got a function that looks like this, and you're on the interval from a to b, and you're looking for the highest value, well, the highest value is going to happen at the endpoint. Right? Lowest value is going to happen at the endpoint. Right? So this function right here has an absolute maximum of whatever that y value is. It happens at whatever this x value is, right? That's the absolute max, and down here is the this y value is the absolute min. But generally, we don't call them local, or let's call them endpoint maxes and endpoint mins. Okay, so I will stop right here and make another video.